interfacing with 7-segment LEDs display. First of all, you have to know the configuration of 7-segment LEDs display. It has two types of 7-segment. First is common cathode and the second one is common anode. If you look at carefully with the common cathode and common anode, so let's say you see here A at the pin A and the segment A here. How do you want to turn on A pin here? So it will same as positive direct drive LED. So if you put VCC or 1 here, and this one must be connect to the ground. And same as common anode, but it will use inverse direct drive. If you want to turn on A, so this one must be ground and this one must be VCC. Okay, the difference is common cathode, at the pin you have to give high, and other pin it will be grounded. And for common anode, at the pin you have to give ground, at the other end is VCC. Okay, normally we are using common cathode, but it doesn't mean that you cannot use common anode. Okay, if you want to use a lot of 7 segments, so you have to make sure you buy the same common cathode or common anode. Don't mix, because it will make you difficult to configure in the programming later. Okay, this is a very simple and very straightforward how to connect the 7 segment to the HCS12. Okay, so let's say assume the output is to display 1 and 2. So you want to display 1 here and 2 here. Okay, this one is 1, this one is 2. Okay, with different ports. So let's say here we use port B and here is port A, for example. Okay, how do you write the program? So let's say here we use common cathode. This must be common cathode because this connected to the ground. Sorry, the common cathode suppose only have 2 pin, only 2 pin only. We don't have a lot of pin here, just 2 pin. Okay, here ground and ground, or VCC and VCC, just 2 pin, and the other pin is for segment. Okay, determine the type of 7-segment LEDs display. So either it is common cathode or common anode, as I mentioned to you, because we are using ground here, so it is common cathode. Okay, and then every port is connected to the every segment, and we put the resistor. Okay, let's say we want to use all port B and port A. So we have to assign all port A and port B must be high because it is an output. Okay, so every port B and port A must be high because it is output. Okay, and then how do you want to turn on the B and C segment? And here you have to turn on A, B, C, no, D, E, and only G. The rest must be low. So what you have to do, just write down into the table. We have A until G and DP, decimal point, and A is connected to the B0, B connected to the B1, and same as A connected to the A0, B connected to the A1, and so on. So you want to turn on for number 1 B and C only. B and C, that is number 1. The rest must be low. So you will get 0, 0, 0, 0, 0, 1, 1, 0. So you get 0, 6 for port B. And port A, you want to turn on A, B, D, E, G. A, B, D, E, G. So 1 here, 0, 1, 0, 1, 1, 0, 1, 1. So you get 5B. So very simple, the programming. So to configure all pins as output, FF DDRB, FF DDRA, and to turn on the segment 1 at port B, so you get 06, go to the port B, and turn on the segment 2 at port A, so give 5B to port A. So finish your programming. This is very simple. But the Dragon board, we use the multiplexing 4 digits of 7 segment display. So we share the port B. So for 4 display, okay, 1, display 2, display 3, and display 4, we share the same port, that is port B. Port B0 is connected to the A segment, port B1 to the B, and so on. Okay, so this is multiplexing. Means you have multiple input, but you have one output. So